Okay, hi everyone, welcome to this video series. Today we're going to be starting a new series called data centers. So what's a network? The dictionary defines the word network as a group or system of interconnected people or things. Similarly, in the computer world, the term network means two or more connected computers that can share resources like data and applications, office machines and internet connection, and some combination of these as shown in figure 1.1. Okay, figure 1.1 shows a really basic network made up of only two host computers connected together. They share resources like files and even a printer hooked up to one of the hosts. These two hosts talk to each other using a computer language called binary code, which consists of lots of ones and zeros in a specific order that describes exactly what they want to say. Next, I'm going to tell you about local area networks, LANs, how they work, and even how we can connect LANs. Then later in this chapter, I'll describe how to connect remote LANs through something known as a wide area network, LAN. The local area network. Just as the name implies, a local area network is usually restricted to spanning a particular geographic location like an office building, a single department within a corporate office, or even a home office. Back in the day, you couldn't put more than 30 workstations on the LAN, and you had to cope with strict limitations on how far those machines could actually be from each other because of technological advances. That's all changed now, and we're not nearly as restricted in regard to both of LAN's size and distance a LAN can span. Even so, it's still best to split a big LAN into smaller logical zones known as work groups to make administration easier. In a typical business environment, it's a good idea to arrange your LAN's work groups along department divisions. For instance, you would create a work group for accounting, another one for sales, and maybe another for marketing. You get the idea. Figure 1.2 shows two separate LANs, each as its own work group. So here you can see the servers for the marketing domain, and then you can see two servers here, and that's for the sales part of work group, and obviously the marketing work group as well. First, don't stress about the devices labeled hub and switch. These are just connectivity devices that allow hosts to physically connect to resources on a LAN. Anyway, back to the figure. Notice that there's a marketing work group and a sales work group. These are LANs in the most basic form. Any device that connects to the marketing LAN can access the resources on the marketing LAN, in this case servers and printers. If you want to access resources from the sales LAN, you must connect directly to the sales LAN. There are two problems with this. You must be physically connected to each LAN to get resources from that specific workgroup's LAN. You can't get from one LAN to the other LAN and use its server and data printing resources remotely. This is a typical network issue that's easily resolved using a cool device called a router to connect two LANs as shown in figure 1.3. Even though you can use routers for more than just connecting LANs, the router shown in figure 1.3 is a great solution because the host computers from the sales LAN can get to the resources, servers, data and printers of the marketing LAN and vice versa. Now you might be thinking that we really don't need a router, that we could just physically connect the two work groups together with a type of cable that would allow the marketing and sales work group to hook up somehow. True, we could do that, but if we did, we would have only one big cumbersome work group instead of separate work groups for marketing and sales. And that kind of arrangement isn't practical for today's networks. This is because with smaller individual yet connected groups, the users on each LAN enjoy much faster response times when accessing resources, and administrative tasks are a lot easier too. Larger work groups run more slowly because in them a legion of hosts are all trying to get to the same resources simultaneously. So the router shown in figure 1.3, which separates the work groups while still allowing access between them, is a really great solution after all. So now let me define the other terms I've used so far: workstations, servers and hosts. Common network components. There are a lot of different machines, devices and media that make up networks. Right now I'm going to tell you about the three most common: workstations, servers, hosts. Workstations are often seriously powerful computers that run one central processing unit CPU, and whose resources are available to other users on the network and access when needed. Don't confuse workstations with client machines, which can be workstations but aren't always. A client machine is any device on the network that can ask for to resources from a workstation, for instance a printer. Servers are also powerful computers. They get their name because they truly are at the service of the network and run specialized software for the network's maintenance and control, known as the network operating system. It's a good design that optimizes network performance. Servers are highly specialized and are there to handle one important labor-intensive job. This is not to say that a single server can't do many jobs, but more often than not you'll get better performance if you decide to dedicate a server to a single task. Here's a list of common dedicated servers. File servers store and dispense files. Mail server, the network's post office, which handles email functions. Print server manages all printers on the network. Web server manages web-based activities by running hypertext transfer protocol HTTP for storing web content and accessing web pages. Fax server, the memo maker that sends and receives paperless faxes over the network. Application server manages network applications. Telephony server handles the call center and call routing and can be thought of as a sophisticated network answering machine. Remote access server provides remote users with access to the network through modems or an IP connection or wirelessly. Proxy server handles tasks in the place of other machines on the network. Okay, as I was saying, to the point of this book, you can think of servers as usually being dedicated to doing one specific important thing within the network, but notice that I said usually. Sometimes they have more than one job, but whether servers are designated for one job or are network multitaskers, they all maintain the network's data integrity by backing up the network's software and hardware, and no matter what, they all serve a number of clients. Back in figure 121 showed you an example of two really simple LANs, and I want to make sure you know that servers must have considerably superior hard drive space and a lot more than the simple workstation's capacity, because they may serve many client machines and provide any resources they require. Because they're so important, you should always put your servers in a very secure area. My company servers are in a locked server room because not only are they really pricey workhorses, they also store huge amounts of important and sensitive company data, so they need to be kept safe from any unauthorized access. In figure 1.4 you can see a network populated with both workstations and servers. You can also see that hosts can access the servers across the network. Pretty much the general idea of having a network. You probably noticed that there are more workstations here than servers, right? Think of it. Why that is, if you answered, that's because one server can provide resources to what you can sometimes be a huge number of individual users at the same time, but workstations don't. You've got it. So here is figure 1.4. Here's our servers. are different work groups: marketing and sales, and hosts. It can be kind of confusing because when people refer to host, they really can be referring to almost any type of networking devices, including workstations and servers. But if you dig a bit deeper, you'll find that usually this term comes up when people are talking about resources and jobs that have to do with transmission control protocol, internet protocol, TCP/IP. The scope of possible machines and devices is so broad. In TCP/IP speak, a host is any network device with an IP address. Yes, you'll hear IT professionals throw this term around pretty loosely, but for the Cisco exam, stick to the definition being network devices including workstations and servers with IP addresses. Here's a bit of background. The name host harkens back to the Jurassic period of networking, when those dinosaurs known as mainframes were only intelligent devices to roam the network. These were called hosts whether they had TCP/IP functionality or not. In that bygone age, everything else in the network scape was referred to as dumb terms because only mainframes hosts were given IP addresses. Another fossilized term from way back then is gateways, when used to refer to any layer 3 machines like routers. We still use these terms today, but they've evolved a bit to refer to the many intelligent devices populating our present day networks, each of which has an IP address. This is exactly the reason why you hear the host used so broadly. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.